Hello, ma'am. Ma'am, make me host, ma'am.
Good evening, sir.
Yeah, ma'am, please make me host, ma'am. Good evening. So we've been learning amines or compounds containing nitrogen. We have learned the theory part in the previous classes. And today we shall finish with the competitive question MCQs based on the compounds containing nitrogen. And maybe from next class onwards, we'll start with a new chapter. So the theory of this chapter is dealt in detail. So we'll continue with the MCQs. The conversion of benzene diazoxide chloride to bromobenzene can be accomplished by Riemer-Tiemann reaction, Friedel-Crafts reaction, Gattermann-Koch reaction, azo-coupling reaction. Now, benzene diazoxide chloride has a molecular formula C6H5 N double bond NCl bond Cl. This is benzene diazoxide chloride. Benzene, 2 nitrogen diazo and chlorine, therefore benzene diazoxide chloride. It is abbreviated as BDC. This benzene diazoxide chloride reacts with copper powder. It reacts with copper powder in the presence of hydrogen bromide to form bromobenzene. So what happens is these 2 nitrogen atoms gets eliminated as nitrogen gas, and this Cl and this hydrogen gets eliminated as HCl. In place of this Cl, what goes? The bromine atom goes. Therefore, you get a benzene ring and you have a bromine here, and this will be called as bromobenzene. This reaction is called as Gattermann's reaction. This reaction is called as Gattermann's reaction. Hence, the answer for this question is option C. The second question, C7H9N has how many isomeric forms that contains a benzene ring? C7H49 having one benzene, maybe they're asking isomeric forms that contain a benzene ring. At least it should contain minimum of one benzene ring. So if we write like this, C6H5 or C6H4, you have NH2 and CH3. 6 carbon atoms and plus 1, 7 carbon, C7. 5 nitrogen, hydrogen, 6, 7, 8, and 9, H9. And we have 1 nitrogen. So this is the first structure. The second one we can write as benzene ring, NH2, and you have what? SCH3. This also has same molecular formula. Another one is we can represent it in the para position, NH2 and CH3 para. The next molecule possible, we can write C6H5, CH2 and NH2. 4 hydrogen, 5, 6, 7, 8, 9 hydrogen. 1, 2, 3, 4, 5, 6, 7 carbon. And 1 nitrogen. Therefore, the molecular formula is same, C7H9 and N. One more molecule we can represent here, a benzene ring. We can represent an isomer like this, NH and CH3. This also has the molecular formula C7H9 and N. Now, all these, when we represent it, all are primary amines because nitrogen is bonded to only 1 carbon. Here also nitrogen is bonded to only 1 carbon. But here, if you observe, this nitrogen is bonded to 2 carbons. Therefore, it is a secondary amine. So totally, how many isomers possible for a compound with C7H9 and N is all these 5 isomers possible. Hence, the answer for this question is option B. So first 4 is primary and the other one is secondary. The next question, the amine that does not react with acetyl chloride. Compounds containing active hydrogen atoms any compound which contains active hydrogen. What is this active hydrogen atoms? Active hydrogen atoms. Hydrogen atoms attached to nitrogen, oxygen, or sulfur is called as active hydrogen atom. These active hydrogen atoms reacts with acetyl chloride, CH3CO, Cl is acetyl chloride, to form acetyl derivatives. So we should remember, active hydrogen containing compounds reacts with acetyl chloride to form acetyl derivatives. Here they're asking the amine that does not react with acetyl chloride. The amine that does not react with acetyl chloride is CH3 thrice N. So this molecule is a tertiary amine which contains no active hydrogen. Since no active hydrogen atoms, this will not react with acetyl chloride. Hence, the answer for this question is option C. The next question. Now, the following reaction, ethyl chloride reacts with hydrogen cyanide. We get X. This X, when you hydrogenate in the presence of nickel, we get a compound Y. And Y, when you treat it with acetic anhydride, the product, what we get is Z. In the above sequence, what is Z? They're asking what is Z? The first step of the reaction is this ethyl chloride is allowed to react with sodium cyanide. When this ethyl chloride is allowed to react with sodium cyanide, substitution reaction takes place, nucleophilic substitution reaction. Cn minus is a nucleophile, which will displace chlorine. So we get CH3, CH2, and Cn. This is X. This, when we reduce using hydrogen in the presence of nickel, what happens is, now carbon to nitrogen, in cyanide we have a triple bond. 2 hydrogen will attack carbon, 2 hydrogen will attack nitrogen. So therefore, 2 pi bonds will break. When 2 pi bonds break, you get CH2 and NH2. So the product what we get is CH3. You have CH2 already. Here this carbon is forming CH2 now, and this nitrogen is again forming NH2. This is Y. This is Y. This, when you allow it to react with acetic anhydride, CH3C double bond O, O, CH3, C double bond O, and O. This is acetic anhydride. What happens is, one of the hydrogen atom reacts with oxygen. This hydrogen attacks oxygen. So therefore, the byproduct formed is acetic acid. The byproduct formed is CH3COOH, acetic acid. What is the product formed? So in place of this H, this carbon goes. So we get the product CH3, CH2, you have CH2, N, H, and you have C double bond O and CH3. So this is the product we get. So the answer for this question will be option 1, CH3, CH2, CH2, NH, CO, CH3. So answer will be option 1. The next question, predict the product. Now this is an aromatic amine. It's a secondary amine. When it's reacted with sodium nitrite and HCl, what's the product? Now it's an aromatic amine. Since it's an aromatic amine, we can represent again this reaction like this, NH and CH3. Now, we should know that sodium nitrite and HCl will react to form HNO2. The product is HNO2, byproduct in NaCl. This HNO2 is called as nitrous acid. HNO2 is called as nitrous acid. Nitrous acid we can represent as OH, single bond, N double bond, HNO2. So what happens is this hydrogen and this OH gets eliminated as water. When this hydrogen and OH gets eliminated as water, in place of this hydrogen, NO goes. So we can write the reaction structure like this. A benzene ring we can write. We can write, instead of writing the nitrogen here, I write the nitrogen here. To this nitrogen, NO is getting bonded, single bond, N double bond O, and you have the CH3. So we are writing the CH3 here. So therefore, the answer for this question is option A. So this is a secondary amine. So the secondary amine reacts with nitrous acid to form an yellow oily layer of nitroso compound. This is a nitroso compound. This NO is called as nitroso group. So therefore, the answer for this question is option 1. The next question. Aniline in a set of reaction yields the following product. The sequence. See, there's these kind of questions will be there for your competitive exams. The sequence. And you have to answer it in 1 minute. Right? So aniline, we will write aniline like this. You should know this reaction. It's a simple reaction. This aniline, when treated with sodium nitrite and HCl, it undergoes a diazotization reaction. Diazotization reaction is formation of a dye. So the product what we get is you get benzene, N double bond N and Cl, benzene diazonium chloride. This reaction we've been learning in the theory classes in regular. Benzene diazonium chloride. This is A. This benzene diazonium chloride, when treated with cupric cyanide, this nitrogen gas gets eliminated. This chlorine also gets eliminated as cuprous chloride. In place, this chlorine also gets eliminated. Now, carbon attacks this, the cyanide attacks this carbon. So the product what we get is, you get a cyanobenzene. This is option B. This is cyanobenzene. Now, HCl, the byproduct is copper chloride, CuCl2. Now, this is B. Now, this on reduction, this reaction we learned now, this on reduction with hydrogen in the presence of nickel, what happens? The 2 pi bonds between carbon and nitrogen breaks, 2 hydrogen attacks cyanide, and 2 hydrogen attacks nitrogen. Therefore, we get a benzene ring, we have a CH2, and we have NH2. So this is C. This, when allowed to react with nitrous acid, HNO2, we can write it like this. So what happens is, this H2 and this O gets eliminated as water. These 2 nitrogen atoms, this nitrogen and this nitrogen gets eliminated as nitrogen gas. So in place of NH2, OH goes. So the product what we get is a benzene ring, CH2 and OH. We will get benzyl alcohol. We will get benzyl alcohol. The product formed is benzyl alcohol. Hence, the answer for this question is option D, benzyl alcohol. The next question, I'll erase this part. This, all right, we'll write it later in the down. Now the question is, in a reaction, aniline is colored. Aniline, a colored product C was obtained. So in a reaction, this is aniline. This aniline is A. This, when it's allowed to react with sodium nitrite and HCl at 0 to 5 degrees Celsius, we know that we get a molecule called as a benzene diazonium chloride. We will represent benzene diazonium chloride like this, N2 and Cl. This is B. Now, this benzene diazonium chloride, when it is allowed to react with this molecule, it's a tertiary amine, aromatic tertiary amine. So what happens? We can show the hydrogen atom here. For understanding, we'll show this hydrogen atom here. This hydrogen and Cl gets eliminated as HCl. When hydrogen and Cl gets eliminated as HCl, we have a benzene ring We have N2. You have this benzene ring now, the other benzene ring, and we have nitrogen, and we have CH3 and CH2. So the product formed is option. Fourth option, you can see this N2, you can write as N double bond N also like this. So the answer for this question is option 4. The product formed is option 4. This is C. The next question. Product Q in the above reaction is product Q in the above reaction. The reaction is not mentioned, so we will write the reaction. The reaction is this: a benzene ring, you have a cyanide, and you have OCH3. This, when treated with methyl magnesium bromide, we get a product P. This, when hydrolyzed, you get a product Q. What is Q? In the question they've asked. So we can write the reaction like this. It's a cyanide. So a benzene ring, C double bond N, and you have OCH3. This, when allowed to react with Grignard reagent, methyl magnesium bromide. So what happens is magnesium gains electropositive character and carbon gains electronegative character. And here, nitrogen is electronegative. Nitrogen is electronegative, carbon is electropositive. Therefore, what happens? Magnesium attacks nitrogen and the CH3 attacks this carbon. So the product, intermediate product, what we get is, we get a benzene ring, we have C, and this CH3 attacks, I'll write it like this, this CH3 attacks carbon, I'm writing it on top, and you have a double bond, we have nitrogen, and you have MgBr. This is an intermediate compound, this is P. And this, when you hydrolyze, so this water, we can write it as OH and H. OH and H. Likewise, another molecule of water, we can write it as H2 and O. So the bonds between carbon and nitrogen breaks. This is H2. So what happens? The product we get is, we get a benzene ring. You have, oh, this I forgot, right? OCH3 is here. This is OCH3. We have now C, this double bond O we have, and you have a CH3. And the byproduct we will get is ammonia gas, and also you get Mg, OH, and Br. The answer for this question, Q, this is Q. The Q is option 2. This is the product form, option 2. The next question. Aniline, the 9th question. Aniline, when diazotized in cold and then treated with dimethyl aniline, gives a colored product. Its structure would be aniline when diazotized in cold and treated with dimethyl aniline. Dimethyl aniline. It gives it gives a product. Now, aniline is this. Diazotized. This is a known reaction, benzene diacetyl chloride formation. Aniline, when treated with nitrous acid HNO2, the presence of HCl gives benzene diacetyl chloride. This is N2 and Cl. This is the first step. Now, aniline, when diazotized in cold and treated with dimethyl aniline. Dimethyl aniline, the formula of dimethyl aniline is CH3 twice N, and you have a benzene ring. C6H5CH2 is aniline. These two hydrogen, if you replace by CH3, then we call it as dimethyl aniline. So if I have a hydrogen, if I show a hydrogen atom here at this position, and benzene diacetyl chloride, if I write like this, Cl, En double bond N. This is N2, you can write as N double bond N, and this benzene ring. So what happens? This H and Cl gets eliminated. So when H and Cl gets eliminated, we have CH3 twice. You have N. We have a benzene ring. You have nitrogen, N double bond N, and you have a benzene ring. So therefore, the answer formed for this is option 3. So answer is option 3. The next question. What is the end product in the following sequence of operations? What is the end product in the following sequence of operation? Now, acetamide, so it is CH3, CO, NH2. This is acetamide. This acetamide, when we treat it with phosphorus pentoxide is a dehydrating agent. Dehydrating agent. It removes water. It's a dehydrating agent. So what happens is this oxygen and these two hydrogen gets eliminated as water. So we have CH3C and we'll get a triple bond nitrogen. This is A. This is triple bond. Since oxygen and two hydrogen are eliminated, carbon to nitrogen forms a triple bond. This is called as acetonitrile. Cyanides are also called as nitrile. This on reduction with 4H. So two hydrogen attacks carbon, two hydrogen attacks nitrogen. Two pi bonds will break. This and this pi bond will break. So what is that we get? We get CH3, CH2, and NH2. This can be written as C2H5 NH2. C2H5 NH2. So therefore, the answer for this question is option 2. The next question. Name the end product in the following series of reaction. Name the end product in the following series of reaction. So acetic acid, CH3COOH. It is acetic acid. When this is allowed to react with ammonia, ammonia is a very well-known base. Acid and the base reacts to form salt. The salt formed is CH3COONH4. This is called as ammonium acetate. Ammonium acetate. This is A. Now this ammonium acetate, we can write, instead of writing CH4, we can write for our understanding, CH4 is written as H2 and NH2. So what happens? On heating, it undergoes a loss of water. When it undergoes a loss of water, we get CH3, CO, and NH2. This is called as acetamide. We get the product acetamide. This is B. This, when you heat it with P2O5, phosphorus pentoxide is a dehydrating agent. So this two hydrogen and this oxygen gets eliminated as water. So the product what we have is CH3, C, and N. So it is a cyanide. This is called as acetonitrile. Called as acetonitrile. Hence the answer for this question is option 3. Acetonitrile. The next question. R single bond N double bond O and a coordinate bond O, and R single bond O, single bond N, R double bond O. Now you can see the molecular formula in both the cases are same. Since the molecular formula in both the cases are same, and here the functional groups are different. Since the functional groups are different, it is through nitrogen it's bonded, here it's through oxygen. Functional groups are different. These are example for a functional isomer. Hence the answer for this question is option 2. The next question. Primary nitroalkanes. Primary nitroalkanes on hydrolysis gives. Primary nitroalkanes on hydrolysis gives. Now, primary nitroalkane, generally we represent it as RNO2. This primary nitroalkanes, when you hydrolyze in the presence of an acid, like dilute HCl. So what happens is this nitro alkanes will be oxidized to a carboxylic acid and hydroxylamine. So nitroalkanes on hydrolysis gives a carboxylic acid and hydroxylamine. Hence, the answer for this question is option 1. If you take a nitromethane, and if you hydrolyze this nitromethane in the presence of an acid, we get acetic acid and we will get hydroxylamine. So therefore, the answer for this 13th question is option 1. The next question, the number of primary amines possible for the formula C4H11N, primary amines. So number of primary amines possible, C4H11N. So we shall write CH3, CH2, 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 and NH2. They're asking primary amine. This is a primary amine, C4H11 and N. Second one, if we write like this, CH3, CH2, CH, NH2, and CH3. This is also a primary amine because nitrogen is bonded to one carbon. Second person. If you represent a molecule like this, CH3, 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 and NH2. This is also a primary amine because the nitrogen is bonded to only one carbon. Now, if we write a molecule like this, CH3, CH, CH3, CH2, and NH2. This is also a primary amine. All these 4 molecules contains the molecular formula C4H11N. Therefore, the number of isomers possible for a molecule with the C4H11 and N is 4. The next question. The type of isomerism shown by C6H5CN and C6H5NC. So here the functional group is cyanide and here it is isocyanide. So therefore, functional groups are different. Hence, the answer for this question is functional isomer. It is option 2. The next question. The product D in the following sequence of reaction is. So it's a lengthy reaction. We have learned this reaction, at least till the product C we have been learning. This is an addition. We will learn acetic acid when reacted with ammonia. Acid and a base reacts to form salt. So the salt formed is ammonium acetate. NH4, NH3 and H gives you NH4. I've written NH4 like this, H2N and NH2. This is nothing but ammonium acetate. This ammonium acetate is A. This, when you heat it, we get P. So water gets eliminated. So when water gets eliminated, the product what we get is acetamide, CONH2. It is B. This is B, and the name of this B is acetamide. This, when you heat it with or treat it with phosphorus pentoxide, this phosphorus pentoxide is a dehydrating agent. Water is removed. So we get CH3, C, and acetonitrile. The product what we get is acetonitrile. Now this acetonitrile, when it's allowed to react with sodium in ethanol, the sodium in ethanol is also a good reducing agent. Since sodium in ethanol is also a good reducing agent, what happens? 2 hydrogen attacks carbon, 2 hydrogen attacks nitrogen. Therefore, we get CH3, CH2, and NH2, or we get a primary amine. The answer for this question is option B, or 2, it is amine. The next one, the 17th question. An aromatic primary amine with cold nitrous acid lead to the formation of aromatic primary amine, a formation of benzene diazoxide chloride. This is aniline. When allowed to react with nitrous acid, we can write nitrous acid as O double bond N OH in the presence of HCl at 0 to 5 degrees Celsius. So what happens is this O and this H2 gets eliminated as water. This H and this OH gets eliminated as water. So 2 moles of water gets eliminated. What is left out? We have a benzene ring. We have nitrogen, double bond nitrogen, and you have a Cl. This is called as benzene diazonium chloride. It's a red colored dye. It's a red colored dye. So the answer for this question is option 3, diazonium salt. Now the next question, the least basic aqueous solution among the following. The least basic aqueous solution among the following. Now you should remember, in all these, nitrogen will have lone pair of electron. Now they're asking which is least basic. The basicity is depending on the ability of this nitrogen to give electrons. In case of aniline, if I draw aniline like this aniline is an electron donating group. The electron will move towards the benzene ring. When electron moves towards the benzene ring, availability of a lone pair of electron on nitrogen decreases. When the availability of lone pair of electron on nitrogen decreases, this molecule will not be able to donate electrons as other molecules. This is due to resonance. Due to resonance, there will be no electrons available on nitrogen. Therefore, the basicity of this will be the least or decrease. So amongst these, the basicity of aniline is least. Due to resonance, the electron pair will not be available. Hence, the answer for this question is option 4. The next question, which one of the following on reduction with lithium aluminium hydride gives a secondary amine or yields a secondary amine? So we can write CH3 N triple bond C. See, secondary amine we want. If we take a cyanide, we will get primary amine. Here you have H2 and here also you have H2. On reduction, it gives you a primary amine, CH3, CH2, and NH2. Now, since they're asking for a secondary amine, we need to use isocyanides. So this on reduction, 2 moles, or maybe we can say 4 hydrogen atoms. Lithium aluminum hydride is a strong reducing agent. So 2 hydrogen attacks nitrogen, 2 hydrogen attacks carbon. So 2 pi bonds will break. So we get a molecule CH3, NH2, sorry, it's not NH2. We'll have NH here because nitrogen valency is 3, NH, and we will have CH3. So 3 hydrogen here, I'm sorry, and here it's 1 hydrogen. So you will get a secondary amine. This nitrogen is a secondary nitrogen atom because it bonded to 2 carbon atom. Hence, the answer for this question is methyl isocyanide. The next question. In the reaction, acetonitrile on reduction with HCl and stannous chloride, we get X. When you boil with water, you get Y. The term Y is. Now, the general reaction we will write. R C triple bond N. R is CH3 here. When this is reduced using stannous chloride and HCl, what happens is the pi bonds will break. 1 pi bond will break. When 1 pi bond breaks, 1 hydrogen atom attacks carbon, 2 hydrogen attacks nitrogen. So the product what we get is RCH double bond N single bond H single bond H. This nitrogen will have a positive character and this Cl minus HCl, Cl minus. This is salt. It's a salt. Now, this ion, RCH, double bond NH, H, and plus this, when you boil with water, so what happens is this whole of this gets eliminated as ammonium ion, NH4 plus. So what is left out? We have R, C, you have H, and you have a double bond O. So this is nothing but RCHO. So in case of this molecule, you will have in place of R, CH3CHO. This is called as acetaldehyde. Hence, the answer for this question is option 3. The next question. X and Y in the given reaction is. What are the X and Y? So this is a tertiary amine. This tertiary amine, when we hydrolyze, what is this X and Y? When you heat it in the presence of water, this bond between carbon and nitrogen breaks. Now, when bond between carbon and hydrogen breaks, we can write water as H and here it is OH. So we X is CH3 COOH, acetic acid, and Y is CH3 NH and CH3. This is secondary amine. Therefore, this can be written as CH3 twice NH. CH3 twice NH. Therefore, the answer for this question is option 1. CH3 twice NH. So the next question. Primary, secondary, and tertiary nitroalkanes can be identified by primary, secondary, and tertiary nitroalkanes can be identified by the action of sodium nitrous. So primary, secondary, and tertiary nitroalkanes. The primary nitroalkanes is RCH2 and NO2. This, when we treat it with nitrous acid, followed with treatment with NaOH, it gives a red color. Red color. And if you take a secondary nitroalkane, R2CH and NO2, this, when we react it with nitrous acid and NaOH, you get blue color. And if we take R3C and NO2, when we treat it with nitrous acid and NaOH, colorless solution. So these are called as alpha hydrogen atom. So primary, secondary, tertiary nitroalkanes can be distinguished by the replacement of alpha hydrogen. This alpha hydrogen is replaced by nitro groups. Here, this nitro group will be replaced by alpha hydrogen. But here, no alpha hydrogen, therefore no replacement of NO2 groups. Therefore, this will not impart color. Therefore, it is colorless. So primary amine gives red color, secondary amine blue color. So this 2 alpha hydrogen will be replaced by 2 NO2 groups, red color. Here only 1 alpha hydrogen replaced by 1 NO2 group, blue color. Here no alpha hydrogen, no displacement, replacement of hydrogen. Therefore, a colorless compound is formed when it's second treated with NaOH. Hence, the answer for this question is option 1. Next question. Which of the following statements about primary amines is false? Alkyl amines are stronger bases than aryl amine. True, alkyl amine. Aryl amine will be weak because it will undergo resonance. So availability of lone pair electron nitrogen will be less. Now, the second one, alkyl amine reacts with nitrous acid to produce alcohols. It's also true. Primary amines gives primary alcohol with nitrous acid. Nitrous acid test is a test which is performed to distinguish between primary, secondary, and tertiary. Aryl amines react with nitrous acid to produce phenol. So aryl amine will not react with nitrous acid to form phenol. Therefore, this is the wrong option. Aryl amines are stronger bases than ammonia. Alkyl amine, this is also true. This is a wrong statement. Hence, the answer for this question is option 3. The next question, when sodium nitrite and HCl were added to an amine at 0 degrees Celsius, a colorless gas was evolved and an ionic compound is formed. The amine is, the colorless gas which is evolved is nitrogen gas. It is nothing but the formation of benzene diazoxide chloride. It's an ionic compound. You have a benzene ring, we have N2 plus and Cl minus. It's an ionic compound. So it is an aromatic primary amine. Answer will be option 2. The next question. The compound obtained by heating a mixture of primary amine and chloroform with ethanolic potassium hydroxide is. The compound obtained by heating a mixture of primary amine, CH3CN. Primary amine is NH2. Primary amine is NH2. This, when it's allowed to react with chloroform, CHCl3, and alcoholic potassium hydroxide, this 3K and 3Cl gets eliminated as 3KCl. 1 hydrogen, 2 hydrogen, totally 3 hydrogen will react with 3OH to give 3H2O. And the product what we have is CH3, single bond N, and you have a C. So this is called as methyl isocyanide. This methyl isocyanides are toxic. And this is alkyl isocyanide in general. So this is called as carbyl amine reaction. This is called as carbyl amine reaction. So answer for this question is option 1. The next question. Identify Z in the change. In the following sequence, identify Z. The first part is very simple. So many questions are asked based on this first part. Primary amine aniline, when treated with sodium nitrite and HCl at 280 Kelvin, that is around 0 to 5 degrees Celsius, we get a benzene diazonium chloride, C6H5En2Cl. It's a red colored benzene diazonium chloride. This is X. This, when treated, we have learned this. When we treat it with cuprous bromide and HBr, so you get this nitrogen gas gets eliminated as N2. This chlorine and this hydrogen gets eliminated as HCl. Now this bromine goes in place of this. So the product what we get is, we get bromobenzene. So the answer for this question is option 1. It is bromobenzene. The next question. Among the following, the strongest base is. Now the first one is aniline. The second one is para-nitroaniline. The third one is meta-nitroaniline. The fourth one is C2H5 CH2NH2, C2H5 CH2 NH2. Now, this alkyl group is an electron donating group. Therefore, electron density on the benzene ring increases. Here, all these electrons will be moving towards the benzene ring because NH2 is an electron pair donor. So availability of electron on nitrogen in this aromatic amines decreases due to resonance. But in aliphatic amine, this alkyl group will increase electron density on nitrogen. Therefore, these electrons can be donated much easily compared to all these molecules. Hence, the strongest base is option 4. So Lewis base is defined as electron pair donors are called as Lewis base. Therefore, this is the strongest Lewis base. The next question, the IUPAC name of the given compound is, IUPAC name of the given compound is, we can number it as 1, 2, 3, and 4. Root word is but. Carbon to carbon single bond, therefore it is butane. Since we have an amine, we remove this E and write amine. This amine is at second position, therefore it's written as butane to amine, the name of the molecule. Therefore, the answer for this question is option 2. Few more questions. An alkyl halide Rx on treatment with KCN followed by reduction leads to the formation of an alkyl halide Rx when it's treated with KCN followed by reduction. So what happens is K and X gets eliminated as KX. In place of X, we get CN, so we get RCN. This, when you reduce it, reduction is addition of hydrogen. Any strong reducing agent, lithium aluminum hydride, 2 hydrogen attacks carbon, 2 hydrogen attacks nitrogen. Therefore, the 2 pi bond between carbon and nitrogen breaks. So you get RCH2 and single bond NH2. So it is an example for a primary amine. The answer for this question is option B, RCH2 and NH2. The next question. CH3, CH2, NH2 contains a basic NH2 group, but CH3CO NH2 does not contain. Does not contain. Because acetamide is amphoteric in character. In CH3, CH2, NH2, the electron pair of nitrogen delocalized by resonance. No, this molecule will not undergo resonance. CH3, CH2, NH2 is there's no resonance. While in acetamide, one lone pair of electron atom in the nitrogen atom is delocalized, therefore less available. So in case of CH3, C double bond O, NH2, this electron can undergo resonance. So you get CH3, CO minus, and you'll get C double bond N, NH2. So that means availability of nitrogen, pair of electron nitrogen decreases. Therefore, basicity decreases. But here, the CH3, CH2, NH2 is not undergoing resonance. Therefore, this pair of electron can be donated easily. Therefore, this will be a stronger base compared to this. Answer for this question is option 3. The next question, dehydration of amide gives dehydration of amide, CH3, C double bond O, NH2. Dehydration is removal of water. These 2 hydrogen and this oxygen gets eliminated as water. So we have CH3, C triple bond N. So we get cyanides. Answer for this question is cyanides. Option 1. The next question. The compound that will not undergo Hoffman's bromide reaction. Hoffman's bromide reactions will be undergone by the compound that will undergo. So amides will undergo Hoffman's bromide reaction. Amides are RC double bond O, NH2. Amide is molecule which contains CO NH2 group as a functional group. Hence, option 3 has CO NH2 group. Hence, this will undergo Hoffman's bromide reaction. Hoffman's bromide reaction is conversion of an amide into an amine by reacting with bromine and potassium hydroxide solution. So you get an amine CH3, NH2 plus you will get 2 KBr and you will get K2CO3 as a byproduct, and also you will get 2H2. So conversion of an amide to an amine using bromine and potassium hydroxide solution is called as Hoffman's bromamide reaction. Hence the answer for this question. For this question, only amides can undergo Hoffman's reaction. Option 3. The next question. The reagent needs to convert acetamide to methylamine. Acetamide, there's a CH3, double bond O, NH2. This to methylamine, CH3, NH2. Amide to amine. It's an Hoffman's bromamide reaction. Hoffman's bromamide reaction. Now, in order to perform Hoffman's bromamide reaction, we require bromine, potassium hydroxide, or we can use bromine and sodium hydroxide. Therefore, the answer for this question is option 1, sodium hydroxide and bromine. Now, we have a diamine, aromatic diamine. This aromatic diamine reacts with sodium nitrite and HCl to form this compound. This is H. To form this compound. Now, what is this? The above reaction is an example for intermolecular CN coupling, intramolecular CN coupling, intermolecular NN coupling, intramolecular. See, within the molecule, these nitrogen atoms are coupled. Therefore, it is called as intramolecular AN-N coupling. This next reaction. This is aromatic primary amine reaction with chloroform and potassium hydroxide. It is carbylamine reaction. This NH2, when reacted with chloroform and potassium hydroxide. So this 3 KCl gets eliminated, and this 3 hydrogen gets eliminated as water, 3 KCl, 3 water, and we get a cyanide. Here, N and C. Isocyanide. This is X. This, when we reduce using lithium aluminum hydride, followed by hydrolysis, reduction. So what happens? 2 hydrogen attacks nitrogen, 2 hydrogen attacks carbon. So you get a benzene ring, 1 hydrogen here and 3 hydrogen here, H3. So you get, say, a secondary amine. So the answer for this question is option 1. C6H5 is represented as pH, phenyl group. So we will learn the next set of, possibly new chapter we will learn in the next class. Thank you.